When you're just sitting on your couch watching a live sports broadcast and the camera zooms in perfectly
Right.
on a player's face from all the way across the stadium, it just feels so effortless. I'm your host, and welcome to today's deep dive.
And I'm here to help unpack the tech, because the real magic of the broadcast isn't actually the camera lens.
No, it's really not. It's this invisible high-speed highway carrying a massive amount of data. And the unsung hero making this possible is, well, it's a $375 box called the DVIGear DVI-7348-TX.
Yeah, so our mission today is really to just unpack the mechanics of that highway for you.
Yeah.
We're looking at how massive, uncompressed video feeds travel flawlessly across huge distances,
Right.
completely seamlessly without a single dropped frame.
Okay, so let's unpack this. We're looking at a 12G-SDI fiber optic transmitter. And if you work with video at all, you know that 12G-SDI means pushing raw, uncompressed 4K video.
Which is huge.
Yeah, its data rate's up to, 11.88 gigabits per second. Trying to push that over copper cable is just a total nightmare.
Oh, absolutely, because of the bandwidth bottlenecks.
Right, so this device shifts it to pulses of light over a single strand of single-mode optical fiber. It's less like, a guy blinking a Morse code flashlight.
Right.
And more like taking a chaotic 12-lane highway of heavy electrical data and just instantly funneling it onto a single fictionless high-speed rail line.
I really like that high-speed rail analogy because it really highlights the sheer bandwidth of the optical conversion.
Yeah.
And what's crucial here is why we have to ditch the copper highway in the first place. At nearly 12 gigabits per second, standard copper cables suffer severe signal degradation over distance.
It just falls apart.
Exactly. And worse, they act like giant antennas for environmental noise.
Oh, right. Yeah.
So by converting the electronic data to light, fiber optic transmission becomes entirely immune to RFI and EMI.
Which is radio frequency and electromagnetic interference.
Right. Exactly. So all those, buzzing radios and heavy power lines at a massive live event, they literally can't touch the video quality.
It just stays pristine.
Yep. Absolutely pristine.
And, distance is the other massive factor here, because you're no longer limited to, maybe 100 feet of cable?
Right, not at all. Because light travels with so little attenuation through single-mode fiber, you can send that flawless 4K signal up to 6.2 miles away.
Wait, over 6 miles?
Yeah, and if you're using the extended version, it goes up to 25 miles.
Okay, wow. But think about that. If you're running fiber 25 miles, that transmitter box is definitely not sitting in some nice climate-controlled server rack.
Yeah, well, definitely not.
It's strapped to a camera rig out in the elements, which actually explains the completely insane temperature rating on this thing.
Yeah, it's pretty wild.
It handles everything from negative 40 degrees all the way up to 185 degrees Fahrenheit. Like, are they broadcasting from inside an active volcano?
It sounds like it, right? But think about a camera rig baking right on the black asphalt of a Formula One track in July.
Oh, yeah. Okay, that makes sense.
And that's where the mechanical engineering really has to match the optical engineering. The device is housed in this heavy-duty die-cast metal enclosure.
Right.
But that metal isn't just physical armor against drops or impacts. It actually functions as a massive thermal heat sink.
Oh, so it cools itself.
Yeah, it actively draws the internal heat generated by the optical laser away from the delicate components inside.
While still surviving the external heat of that sun-baked asphalt.
Exactly. Combine that with locking 75-ohm BNC connectors that, they won't shake loose on a vibrating camera mount.
Right.
And you have something that's just built to be utterly fail-proof.
Well, and it has to be fail-proof, especially when you realize it's carrying way more than just video.
Yeah, definitely.
Because it also passes RS-485 serial data, which means a director miles away isn't just passively receiving a video feed.
No, they're actively engaged.
Right. They can actually remotely control the pan, tilt, and zoom movements of that camera over the exact same fiber strand.
Yes. It's all multiplexed together.
Yeah.
It even supports tally light control.
Oh, wow.
Yeah, so that director, sitting comfortably in a broadcast truck, maybe miles away, can instantly trigger the red indicator light on the camera.
Just letting the talent know they are live.
Exactly. They have total bidirectional control over the acquisition hardware.
Without anyone needing to, stand out in a heat wave or a blizzard to troubleshoot.
Exactly. It's totally seamless.
It really shifts your perspective, True broadcast magic relies on these tiny, rugged gadgets quietly doing the heavy lifting in the background.
It really does.
Without that invisible bridge rapidly converting data to light through the extreme heat and cold, the screen just goes blank.
Which raises an important question to leave you with today.
Yeah.
The next time you watch a live event, broadcast from a harsh environment, take a second to think about those tiny pulses of light traveling miles underground to make it happen.
It's crazy.
It is. And it makes you wonder, what other invisible, rugged technological bridges are operating right now that we completely take for granted in our daily media consumption?